Okay, yeah, no, I'm coming to the meeting. I'm just running about 15 minutes late. I'm on my way right now. Okay, bye. I'm driving along the freeway at 55 miles an hour, yet thanks to computers, I'm able to carry on a normal phone conversation. This cellular telephone depends on computers to hand off my conversation from one relay station to another. It's just one example of how computers and telephones are working together now to bring us a whole new array of technologies. Today, we take a look at computers and communications on this edition of the Computer Chronicles.
The Computer Chronicles is brought to you in part by McGraw-Hill, publishers of Popular Computing, the magazine that gives readers an understanding of the technology and applications of microcomputers and software in office, home, and classroom.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and this is Gary Kildall. And Gary, this nifty little device I have here is actually a computer terminal. I'm right now accessing a Mini in Washington via satellite and FM transmission, and I can actually ask the computer back there in Washington for some stock quotes, for example, and I can see right now information that I'm getting through this computer out of Washington. This is a good example of a computer, and there's an antenna communications. In general, Gary, how do those two technologies complement each other?
I think this is a very good example of that. In the days of time sharing, we shared computer resources and data, but personal computers brought a lot of that computing and the personal data right onto your desk. And the personal data are things like your letters and your spreadsheets and the programs that you've written. But a lot of data can't be personalized. There are things like large and changing databases, electronic mail, a variety of these things that are dynamically changing every day. Now that's where communications is really important. With a personal computer, then it lets you get at that information that's dynamically changing that can't be locally generated or produced.
On today's program, we're going to see how you can use a touch-tone phone as a computer terminal. We'll watch color graphics being transmitted on a phone line, and we'll visit AT&T's Bell Labs in New Jersey. Let's begin first with a background look at what's been happening with computers and communications.
The link between computers and communication is a natural one. Early computers were fast electromechanical switching devices, often relying on the same simple relays used by the telephone company. The soft clicking of relay switches was audible proof that messages were being transmitted, but faster and denser signals were the key to faster communication. And today, what the integrated circuit did for the computer, fiber optics and digital code are doing for the telephone. As part of a nationwide experiment, eastern Pennsylvania is being wired with a fiber optic network capable of transmitting 1.7 billion bits of data per second, or about 170,000 simultaneous conversations. Lasers transmit the data in pulses, representing digital bits. Since there is no need to translate digital to analog signals, the fibers can carry computer data just as easily as voice data. Your phone line becomes a computer network. Customers taking part in the Harrisburg experiment can choose some remarkably intelligent telephones. One attachment features an LCD readout that gives you the number of the person calling you and stores calls as they accumulate during your absence. There are phones that remember the last call you dialed or the one you just missed, and you can program your phone to identify callers with programmed rings. The system is also capable of tracing a call and will even reject calls from people you would rather avoid. While some of these arcane services may not suit everyone, they point the way towards a new era in telecommunications. Computers inside telephones and telephones inside computers.
With us now in the studio is William Gillis. Bill is Executive Vice President of Schwab Technology Services, a division of Charles Schwab & Company. Bill has been with RCA, the Bell System, and Mattel Electronics. Next to Bill is Bob Metcalf. Bob, the founder and chairman of 3Com Corporation, a PC networking company. Bob was formerly with Xerox PARC, and Bob is the inventor of Ethernet.
Bob, you know, there seems to be two classes of users, I guess, of personal computers. Those that are used in the business and office and the individual. And as individuals, we seem to have inherited the phone system as our way of communication. Is this going to place any really inherent limitations on what we can do with the computer communications?
Well, our personal computers are getting smarter and smarter very quickly, and as they do so, they want to communicate more and more information, and the 100-year-old telephone network is beginning to be stressed.
Is this going to be improved? Is there going to be improvements in the way, the rates at which we can communicate?
Absolutely. There's a lot of progress being made among the telephone companies to increase the amount of data they can carry, but also cable TV companies and other means are being developed as well.
Explain, Bob, the importance of moving to a digital rather than an analog kind of phone system.
Starting 10 or 15 years ago, digital electronics began to reduce the cost of voice communication, but now more and more, by going digital, not only you're reducing cost, but you're providing communication more suited to computer communication.
And Bill, you have an example here of how we do the kind of thing Bob was talking about. Let's start off with I think what you call Schwab quotes in that telephone.
Sure, it's a telephone-based stock quotation and news service that's accessible from any touch-tone telephone. I could give you an example of that.
Please.
I'll quickly dial in to our system, although you can dial from any touch-tone telephone. You don't need a special phone like the one that I'm using today.
Welcome to the Schwab Quote Service. Please enter your account number.
My account number
Now enter your password.
and my password.
So you're basically using just a telephone as a kind of computer terminal to access another computer's database.
That's exactly right.
And so you can place your orders here just like you would through a broker and just do it directly?
Not with the telephone service. I can transfer to a broker, but I can't actually buy or sell with the telephone
Now you
set.
have a computer-based version of this also. Is that true that you're going to show us?
That's correct. And that one will allow you to actually buy or sell. I can show you that. You can do actual research, you can buy or sell stock, or maintain your portfolio. In this case, I think I'll buy some of Bob's company.
Okay. So you're going to give us a demonstration of how you can use this software package to be your own broker, in a sense?
That's correct. This package called the Equalizer that allows you to buy, sell, do your research. I'll just call up a portfolio and put in a buy order by typing the letter B, COMS being Bob's company, and I'll buy his common stock by indicating an S and 100 shares.
Okay, you're not actually online yet, Bill,
I'm not online yet, and that's one of the beauties of the system. It allows you to format your orders before you actually go online, which saves in communications cost. And I don't know the cost of the product, so I will ask for the market price and then a day order, which I've now accepted. And at this point, I will actually sign online to actually buy the stock.
Okay. Now this is a good example, again, of what we were talking about earlier, in the sense that there's some local computing going on here, preparation of the order, getting it all set and ready to go, and then you use your phone system to connect to a bigger computer system where the transactions actually take place. The
Correct.
transactions themselves couldn't have been done locally in the personal computer because of the large database.
That's true. There's thousands upon thousands of stocks, and that would overload the capacity of most small computers.
Okay, Bill, you are online now, and what's happening?
We're logging onto the system now. It's actually sending in my trading password, which will be acknowledged. The system now tells me that last time I signed on was earlier this morning. It's receiving data back now, which will allow me to continue the process and finalize placing the order.
And what you're doing here is not really sending an order to a broker somewhere. You're actually placing and executing the order yourself.
That's correct. I'm signed into our host computer. The order would be examined by a broker who would then hit one key to forward it on to the exchanges. In this case, we're now online. To finalize the transaction, I'll just hit two more keys. It's sending the request to buy Bob's company stock, receiving data back, acknowledging now that that has been done, and the order has been placed in our host computer system.
Now, Bob, this is a really good example of using the current technology to good effect. Is there where do you see this going in terms of just, say, an individual getting access to large databases?
Well, the computers are getting, as you well know, smarter and smarter, and as they get smarter and smarter, their appetite for information grows dramatically. So there's a lot of pressure on the telephone companies, again, to accommodate this greater appetite. I think another area that's going to come strongly is the use of PCs, not only for database access, as you just saw here, but electronic mail.
Now, Bob, we hear a lot about AT&T's role in the deregulation and how important that may be to this merger of computers and communications. How important was that deregulation in this technology?
The regulation tended to put a wet blanket on innovation. I think now that a higher level of competition has been introduced, we can expect a higher turnover of equipment to newer technologies, particularly technologies suitable for computer communication.
Well, how about some alternate forms of communication? We hear about satellite transmission and things of that sort. Is that ever going to take place for an individual? So we say we can really get high data rate transfer to an individual rather than, say, a corporation?
I think that's a little further out than you might like, but there are direct broadcast satellite to homes is coming up. Of course, that's one way, and so in order to use computer communication, you'd have to go the next step to have two-way direct broadcast satellite. That's quite a bit in the future.
You mentioned also cable TV. How do you see using cable TV transmission capability with regard to computers?
Well, television has either the pleasurable or the unpleasurable feature that it's one way. That is, we're broadcasting information over TV in one direction. Computers need two-way, but now many ways are being found to apply the cable TV network to do two-way communication, to get data to go through those cables both directions.
But I guess what the real challenge then right now is to use the existing telephone network to its best advantage then.
Well, this whole communication infrastructure is a vast investment, and it's not the sort of thing you want to throw away in a day. So it taxes our ingenuity to think of ways of using that installed base of equipment.
Gentlemen, thank you. In just a minute, we're going to see how you can actually transmit color graphics over a phone line, and we'll take a look at the newest machines from AT&T. So stay with us. AT&T's famous Bell Labs in New Jersey, home of countless technological innovations, but mostly in the field of communications. For up until last year, AT&T was the phone company. But now with deregulation and divestiture, AT&T is free to move into other ventures. And one of its first and biggest new ventures is the move into computers.
AT&T's communication heritage will bring to the computer user the ability to have these computers converse with each other in a natural way, in a friendly way, and make processing and data communications as easy as voice telephony has been made by AT&T and by the direct distance dialing network and other advances such as these.
AT&T's new machines represent a different approach from its first computer products, relying instead on the communications giant's traditional strength, data transmission. At the top of the line is the new 7300 called the Unix PC, designed for multi-user, multitasking applications. It features the overlapping windows of the Macintosh, a Unix operating system, and a telephone manager.
We have given the user, presented this to the user in a way that communications becomes a natural modality at last. We've taken the telephony, just plain old phone, hooked it into the machine such that the user really can control who they're calling. For example, a telephone call would come in, you can put the name of the person who called, and you can have a whole history of your last 5 conversations with that person.
The computer's telephone with a memory and electronic mail are designed to interface with AT&T's new 1 megabit network, providing fast, all-digital transmission of both voice and data simultaneously. Goodbye modem, hello Unix.
It matches the needs of the user to the interface. And it does this by integrating all the communications in a way that it's at your fingertips, and it's as easy as dialing a phone to use a very powerful computer. Now, it's implemented with the Unix operating system, but to me that's a detail. That's our magic. Unix is our magic.
Some industry watchers have characterized the next computer era as a battle between two giants, IBM and the phone company. But AT&T doesn't see it that way.
Yes, IBM's a competitor, but I don't think it's a battle of the titans in terms of the way people say it. I think it's really, in some ways, a real advantage for the U.S. to allow two very strong companies like AT&T and IBM to prepare for the real onslaught, and that's of the Japanese computing.
In fact, the challenge from Japan points out a basic difference between the Japanese and American styles of distributing data. While Japanese research gives high priority to making mainframes more friendly, Americans take a more local approach.
In the U.S., people are fiercely independent and they like to be autonomous. And to me, that says that they need control over their data. The bad news is what we've done is we've created millions of islands of computing that must be linked together. Once we solve that basic problem of making things really friendly, everyone likes to talk about friendly user and fun to use, but really friendly, you know, natural languages, easy to communicate, it's problem-oriented, it solves my problem in the way I think about it. Once we solve that problem, the explosion in what people have called the explosion in the last 3 years in computing will basically look like a foothill.
AT&T seems well positioned to be a major player in the field of computers and communications, having added computers to its communications expertise. But IBM has added communications to its computer expertise by acquiring Rome Corporation, a major telecommunications firm. Robin Garthwaite has more on the IBM-Rome connection.
Opening the lines of communication. That's what Rome Corporation and other telecommunications companies are helping the computer user to do. Now, logging onto a database can be done with a touch of a single button, and voice and data calls can take place at the same time.
We are trying to make accessing data as easy as making a phone call. That is, right now no one thinks twice about picking up their phone and calling someone anywhere in the world. It's much more difficult to do that when you want to call any computer anywhere in the world. And the goal is to make it as simple as possible to do both of those things without having to sacrifice one for the other.
Products such as Rome Cedar give the user not only personal computer capabilities, but also highly developed telecommunication functions.
And these products are really designed for the communication-intensive knowledge worker who can't afford to have to say, I can't get any phone calls, I can't make any phone calls, I'm on the computer right now. The fact that personal computers are becoming more commonplace and people want to do more with them is just putting more and more pressure on the telecommunications industry to respond to that.
New products, new ideas. In the telecommunications field, there doesn't seem to be a limit. But having this much power can present a problem. I think I just ordered a pizza in 15 states. This is Robin Garthwaite for the Computer Chronicles.
Stewart, it appears that for at least this point in time, the big question is how do we get the most out of our existing telephone network?
Well, Gary, I think we have a pretty good example of how you do something pretty impressive with the phone company. Let me introduce Glenn Albinger. Glenn is the Director of Software Systems for the Computer Colorworks in Sausalito. And next to Glenn is Barry Marjoram, Vice President for Defense Systems Marketing at Grid Systems Corporation. Glenn, I want to start with you. Explain the demonstration you have for us.
Well, I'm linked by modem and telephone to our offices in Sausalito, and I've got the program running, and my colleague Ted at the other end is going to load a map of the area. Ted, load the map. Okay. Just wait for the modem to be sure it's running.
So you're talking to Ted on the phone while your computers are also hooked up to send this graphic.
That's right. And you can't actually do both at once. What we do is we switch between data transmission and talking.
So is this an encoded picture now of the entire screen, or how is this transmission actually taking place?
What's happening is we recorded the motions that the pen, this digitizing pen, took at the other end at one time to make this map.
Okay.
And he's loading that
seeing
disk.
now?
What are we seeing now? He's loading the map, which is just a sequence of lines, or this is an ocean actually. And I can be doing things while he's doing this, but we'll just wait until it's done.
So this sequence of keystrokes that he originally performed were recorded, and then those keystrokes were sent over here and then reproduced then?
That's right.
Okay.
That's right. I wouldn't call them keystrokes exactly,
No,
but it was
keystrokes.
a recording,
Motions,
yes, right.
okay.
Exactly.
So essentially with the phone line, you guys can not only talk to each other, but work on the same graphic at the same time.
That's right. In fact, to give you an example of working on the same graphic at the same time, I can add to this. I'm also recording the session as we go along here. I can add to this while he's sending it over, so I can be...
So if this were some sort of a business presentation or something of that sort, then there could be some interaction going on both sides.
That's right.
Barry, I want to turn to you, if I may. One of the concerns people might have in sending computer data over phone lines, for example, might be the security of that data. You've got a system, I understand, which takes care of that problem. Explain what your new grid system does.
Yes, we recently announced a grid compass computer that has a high-grade embedded encryption in it. And what this allows you to do is when you transmit the data over phone lines or satellite or microwaves, it encrypts the data so that if it were intercepted, it wouldn't be exploited.
Okay, now show me what you're talking about.
Well, as you can see, when we set this up, I have it right now simulating it going over a phone line, although it's just using a null modem. And as I type the information here on this one screen, you can see that I'm getting the identical information on the other screen. By being able to set up the encryption algorithm, you can now see that the data going across the line is in fact different. It almost looks random. And as a consequence, if someone were to intercept that data, they would not be able to make sense out of it. And as a consequence, the data is preserved and the integrity of the system is preserved.
Now, this has obviously military applications. Do you see it also going into the business areas and things?
Absolutely. The military probably is the area that has the most concern about the privacy of data, and although the other parts of the civil government, customs, drug enforcement, FBI, and those folks are also concerned about the security of their data. The commercial world, I think, is probably the next area or market for us to look at, although they haven't seen a need yet to spend the money. I think when a major catastrophe happens, they'll realize that this information is available to those people who have a need to get to it, and certainly the electronic equipment is available to be able to intercept the data and make use of it.
Barry, we have visions of huge supercomputers when we're talking the Defense Department. I mean, somebody's running around with a grid doing something. How would this be used?
Yes, well, it's interesting, Stewart. The interesting thing about the grid compass is because it is portable, it's also very rugged. It's all solid state. There are really no operational moving parts in this, so it does very well in a low shock and vibration environment. As a matter of fact, it could take a 42-inch drop and still work effectively. So from the military standpoint, because it is powerful and because it's lightweight and because it has the communications protocols they look for, it's an ideal system for them to be able to field immediately and take full use of it.
Gentlemen, thank you very much. We're out of time. Gary, this communications and computer stuff is very fascinating, and it's quite amazing to see what it can do. But our commentator, Paul Schindler, asks the question, do we really need all this technology?
What do you mean all the lines to Venus are busy? But seriously, folks, interstellar communications is not only unlikely, it's not even going to be necessary until there's a lot of people in space. Alas, a lot of things that'll be possible with computers and communications won't be necessary, but they'll be done anyway. There'll be more and more access to databases, even though people aren't sure they need them. There'll be more electronic mail, even though most of us would rather some letters weren't delivered so fast. And, of course, the new car telephones are a perfect marriage of computers and communications. They couldn't work without computers. But the question that's not being answered is whether we need all this. As in so many other things, we could learn from the French, who are making sensible use of communications and computers. In France, they plan to throw out all their telephone books. People will look up phone numbers with computer terminals, saving both a lot of money and a lot of trees. You know, I think today's show was a great idea. You ought to get a peek at what's coming down the pike. But my concluding thought is that nobody knows. Nearly every advance in communications surprises most of the experts. Who knows? Maybe the next big change will be interstellar telephone calls. That's my opinion. I'm Paul Schindler.
In the random access file this week, with the industry buzzing about the official release of AT&T's new 7300 series personal computers, Compaq Computer Corporation jumped into the new computer phone market with 6 new products of its own. The new line, dubbed the TC2500 telecomputers, combine an advanced telephone with a desktop computer compatible with the IBM PC. Texas Instruments flexed its muscles this week with the announcement of its new Supermicro. The new computer, called the Business Pro, will be fully compatible and competitive with IBM's hard-to-find PCAT. The basic package includes a keyboard, 512K of RAM, and one 5¼ disk drive for around $4,000. The company expects the move to double its present 1% share of the personal computer market. In the mainframe world, National Semiconductor has announced 2 new products to compete with IBM's new Sierra line of mainframes. The company promises lower prices and a more compact design. And Gene Amdahl's Trilogy Limited, after giving up on its efforts to build a high-powered business computer, has purchased Alexi, the San Jose supercomputer manufacturer, for $64 million. It seems to be a good match, putting one company, Trilogy, with cash but no customers and no product, together with a company that has a product but needs cash to promote it. So you say your spreadsheet isn't big enough? Then listen to this. Boeing Computer Services in Bellevue, Washington has announced Boeing Calc, the first spreadsheet that is not bound by a computer's internal memory, but rather by its online storage. Boeing Calc is said to be truly three-dimensional, with rows, columns, and up to 1,000 pages. Speaking of large spreadsheets, here's Paul Schindler with this week's software review.
What do you think of when you hear the name Higgins? Well, you think of butlers and then classy service. Well, that's just what you get from Higgins, classy service. And you see, PCs create the need for service. They take up a lot of room on your desk. Now, sure, you can use a PC to do a lot of things you couldn't do before, but you still need a calendar, a Rolodex, and an appointment book. Of course, you can get each of these functions in a separate program, but don't you think it'd be nice to have all of them and more in a single computer package? That's just what these people have done. Now, Higgins isn't much to look at first. Just another calendar and date book, you might think. But let's go through a lightning-fast demo, and you'll see it's more than that. It'll auto-dial a phone call for you. When you're done, you can make notes on the call and add an item to your to-do list. Higgins can interconnect all of them. It'll even keep your to-do list in priority order. Now, Higgins isn't simple. It takes some diligence to learn, and it ain't too fast. But if you spend as much time as I do digging around your desk for notes and calling back people you've already talked to, you'll think $400 is a bargain for Higgins from Kinetic Systems in Portland, Oregon. For Random Access, I'm Paul Schindler.
Life in the Silicon Valley's fast lane with fast processors, venture capital, and cocaine is changing. Unlike the 70s, when management and production line workers would take cocaine together, there is now a serious campaign to fight drug abuse. Some firms are hiring private investigators to check out prospective employees. One Silicon Valley firm funded an undercover narcotics investigation of its own plant by local police. In the world of text and image processing comes a new computer at the Handley School for the Blind in Winnetka, Illinois. The first of its kind, the system may revolutionize the publishing of Braille books. It can print 400 Braille characters a second, 600 lines a minute. A new textbook that might have taken a year to produce can now be done in a few weeks. And finally, for those of you working on your taxes, here's a little incentive to be extra careful. It seems Rohn & Haas, a giant Pennsylvania chemical manufacturer, shorted the IRS 10 cents on tax deposits of $4.5 million in 1983. The penalty, $46,806.37. It pays to use a sharp pencil. That's it for this week's Computer Chronicles. I'm Susan Bimba.
The Computer Chronicles was brought to you in part by McGraw-Hill, publishers of Popular Computing, the magazine that gives readers an understanding of the technology and applications of microcomputers and software in office, home, and classroom.